two-transistor model of a thyristor. The regenerative or latching action of a thyristor due to positive feedback can be demonstrated by using two-transistor model of a thyristor. A thyristor can be considered as two complementary transistors. One is PNP transistor Q1 and another NPN transistor Q2. And this is the basic structure of two-transistor model of a thyristor, and this is an equivalent circuit. And the collector current of a thyristor is related to the emitter current IE and the leakage current ICBO0 as shown in this equation number 1. The common emitter gain alpha approximately equals to IC divided by IE. Now, for the transistor Q1, the emitter current IE is nothing but anode current IA. Collector current is IC1. Then IC1 is related alpha 1 of the Q1 IA plus I leakage current of the collector base junction 1. That is equation number 2. Similarly, for transistor Q2, emitter current IE is nothing but IK, IC2 is the collector current. Then the relation is given by IC2 equals to alpha 2 is the current gain and IK plus leakage current ICBO are 2. That is equation number 3. At this junction, if you observe, anode current IA equals to, at this node, IA is coming and IB1, IC1 is going away from the node. So, IB1 plus IC1, where IB1 is nothing but IC2. So, this we can write IC1 plus IC2. Then substituting those values, IA equals to alpha 1 IA plus ICBO01 plus alpha 2 IK plus ICBO02. That is equation number 4. If you observe at this node, IG plus IC1 equals to IB1. If you observe at this section, this is IB1 plus IC2 equals to IK. Now substitute the value of IB here. Then IG plus IC1 plus IC2 equals to IK. And we know that IC1 plus IC2 is nothing but a IA. This will be IG plus IA equals to IK. That is equation number 4. Equation number 4 and 5, IA equals to alpha 2 IG plus ICBO01 plus ICBO02 divided by 1 minus alpha 1 plus alpha 2. That is equation number 6. Now the current gain alpha 1 is going to vary with the emitter current IE, which is nothing but the anode current IA. And alpha 2 is going to vary with the emitter current IE. Here in our case, this is emitter current is IK, which is nothing but IA plus IG. A typical variation of current gain alpha with the emitter current IE. If the gate current IG is suddenly increased, say from 0 to 1 milliamps, and this increase in IG is going to increase the anode current IA, which would further increases value of alpha 2. When IA increases, alpha 1 and alpha 2 increases, and alpha 2 will be dependent on IG and IA. This increase in the values of alpha 1 and alpha 2 would further increases IA. So, a small change in IG is going to increase the value of IA, and this increase in the IA is going to increase the value of alpha 1 and alpha 2, and the increase in the alpha 2 is again going to increase the value of IA and IG. Again IG increases, further increases IA. Therefore, there is a regenerative or positive feedback effect. So, as the alpha 1 and alpha 2 increases, the value of alpha 1 plus alpha 2 is also going to increase and reaches maximum value of unity, resulting in large value of IA. For small value of IG of 1 milliamps, there is a anode current of large value, which we can observe in VI characteristics. This is a large value of anode current versus a VB. And this turn-on can be achieved simply by using a small gate current. Under the transient conditions, the capacitances of PN junction will influence the characteristics of the thyristor. And the transient model is like this. If the thyristor is blocking stage, a rapidly rising voltage applied across the device would cause high current flow through the junction capacitors. The current through the capacitor CJ2 can be expressed as IJ2 equals to dQJ2 divided by dt. That equals to d by dt of CJ2 VJ2, which again in terms we can write this as VJ2 d by dt of A B is given by B d by dt of A plus A d by dt of B, d CJ2 divided by dt plus CJ2 d by dt of VJ2. That is equation number 7, where CJ2 and VJ2 are the capacitance and the voltage of junction J2 respectively. QJ2 is the charge in the junction. If the rate of rise of voltage dV by dt is large, then IJ2 would be large. If this value is large, then IJ2 will be large, and this will result in the increase of leakage current I CB101 and I CB102. According to the equation number 5, high enough value of IB101 and IB102 may cause alpha 1 plus alpha 2 tends to unity and results in undesirable turn on of the thyristor. However, a large current through the junction capacitor may also damage the device.